Hello, everyone. Thank you for joining us. The GeoQ team has been hard at work and is ready to share our upcoming releases with you. In today's webinar, we will be announcing new hardware and software developments. Before we get started, I'd like to go ahead and do an audio check. Please notice the raise your hand button has been circled in red on the slide. If you can hear me, please click this button now. Beautiful. Looks like everyone can hear me. We still have people joining us. Wonderful. My name is Crystal Bailey, and I will be moderating today's session. Joining me is our President and CTO, Louis Graham, and Director of Business Development, Madeline McNabb. Our VP of Special Projects, Martin Flood, and GeoQ Australia General Manager, Mark Hickey, are also with us today and will be answering questions throughout the webinar. Thank you all for joining us today. Before we begin, I would like to go over a few things. Group audio has been disabled for this session. If you would like to ask a question, please use the question box on your GoToWebinar panel. This session is scheduled for 60 minutes. If we do not get to your question during this webinar, we will follow up with you by email. This webinar is being recorded and will be distributed to everyone registered. And at this time, I'm going to go ahead and launch one poll question to get us started. Please indicate your use of drone mapping/inspection technology. Check all that apply. And I'll leave this open for just a second, and I'll share those results with everybody to get a good idea of the user group with us today. All right, go ahead and close that poll and share those results. And it looks like a good majority of people are performing LiDAR and photogrammetric mapping using drones, which is good. All right, thank you for participating in that poll. Go ahead and hide that. Thank you all for voting. Joining me now is our President and CTO, Louis Graham, and I will pass the presentation over to him now.
Hey, thank you, Crystal. Can you see my screen and hear me okay?
Sure can.
All right, well, thanks everybody for joining us. Regardless of your location, we did this in the morning. This is our evening session in the US. Our company was founded, just a little bit of background on us. We founded GeoQ Group in 2003, so we've been around for over 18 years. Now, this is really important when you're out buying drone technology, because a lot of companies have been in business for a short period of time, and there could be questions about, will they be around tomorrow? And, we've been here a long time, and I think we'll be here tomorrow. Our headquarters is in Huntsville, Alabama. We have a business that we started up as a joint venture in Brisbane, Australia, and Mark Hickey is on tonight. He's the general manager of that business. And then we've got an office in Toronto, Canada, that's managed by Martin. We're a privately owned company with a focus in three major areas. So we started out our company with a focus on manned airborne and mobile LiDAR solutions, primarily in software training, data management, and so forth. So all the surround technology it takes to do really high-end production work. We have customers in that space, such as the Department of Agriculture, Geoscience Australia, USGS, and so forth. And then we also do a lot of enterprise solutions. I've got that over on the right-hand side that have become these days mostly based on Amazon Web Services. So, for example, we've built a data management system for a hyperspectral camera that flies on the space station, and we download the data from that and process it and post that up to a site. The primary customer for that data is NASA for climate change research. And then drone mapping is what we're here to talk about today, which has become 63% of our business by gross revenue. And we've got a total workflow solution in that area, ranging from the sensors all the way to the post-processing workflow, as well as cloud-hosted delivery capability. Flown thousands of mapping projects, all of them what I call metric, where we've measured the accuracy of the system since that is our focus. So we don't do much in the inspection arena. We're more interested in how can we accurately do topos, cross sections, volumetrics, etc. We've just recently built a new facility that's allowed us to consolidate all of our operations in one location, including flying. So we have a 7-acre or a 3-hectare campus in an area called Triana, Alabama, which is south of Huntsville. We're right by the Tennessee River, so we've got convenient access for bathy testing. And we've got quite a nice facility here. So once every month, we have a group of people that come in that are prospects for our systems or have already bought systems that do training, from flight operations, where we actually spend a half a day flying the sensors, and then a day and a half doing data processing and so forth. So it's really quite a good experience. I would encourage you, if you're thinking about making a major investment in a system, that might be a good initial step. We have an A list of customers, and it's really interesting to note that more and more of these customers are in the wire space these days, like Tennessee Valley Authority, Lower Colorado River Authority. These are all transmission and power operators. So it's interesting, we're seeing more and more wire extraction being done with drone LiDAR systems. So our focus in our company in the drone arena is to build 3D imaging sensors. So this is camera plus LiDAR fusion. So far, we've not done a LiDAR only system because we think there's so much value in having integrated cameras. So for example, this is really nice. So this is from our TrueView 515 scanner flown at 75 meters. You see great detection of wires. The trees are very well detailed, as well as this drainage ditch. But it'd be nice if we could see just a bit more. And so we have dual cameras, and we fuse the camera data with the LiDAR data. And now we have a colorized point cloud. You can see that this gives much more interpretability to the data. Here I've got the vague notion that I've got a drainage ditch. If you've looked at LiDAR a lot, you'll recognize it. But if I have the RGB colorization, it makes such a difference. So it's not just about pretty pictures, it's about productivity. I can classify the image on the right, or the point cloud on the right, much quicker than I can classify the one on the left. I think we differ from just about everybody else in the business. We do true colorization of the point cloud through ray tracing. So on the left, I've got an image, or a point cloud rather, that's been colorized from an ortho. And you can see that I have the same color on every vertical stripe of this building. And that's because in a digital ortho photo, I have only one color for each XY location. But in a real 3D point cloud, I have many Z values for that same XY location as I move up the vertical slant of this building. When we do our real ray tracing, we project from the point. So I might be on the edge of this building at the top and project these points back to the source images. So you can see I've been able to color that in the red trim of the building. This is in the gray. I've got access door in red, etc. So it really makes a big difference to do this correctly. We brought our sensors to market several years ago with the TrueView 410 based on a Quanergy M8 Ultra laser scanner. After that, we introduced the Regal Minivux system as the high-end system. And then just at the beginning of this year, we introduced the TrueView 515, which is really a great sensor for just all-around sensor for wires, topo, etc. Nice sensitivity in this sensor. All of our sensors follow the same general design paradigm. So we've got dual cameras that are canted at 25 degrees off nadir, one to port, one to starboard, that gives us a full 120-degree image field of view in cross track. All of the scanners that we use have a field of view of at least 120 degrees. This is the Minivux 3 from Regal. And when I'm in the maximum stepping rate, 300 kilohertz, this sensor scans at 120-degree field of view that's perfectly matched to these cameras. So this is really important. These wide fields of view are really nice for a variety of reasons that I'll cover a little bit later on. We use exclusively Trimble positioning technology within our systems. We use the APX 15 and APX 20 from Applanix, which is a division of Trimble located in Canada. Tried, tested, and proven. They've been in this position and orientation business since the 1990s. They really know what they're doing. And then we build our own board stack with the exception of the position orientation system within the electronics housing of the system. So the main difference between our sensors is the scanner itself. And speaking of scanners, I think I've got a shelf full of these things back in the R&D lab. We've bought everything from Livox to Velodynes to, we've got quite a collection that we've spent a lot of money on. We extensively test these systems because except for this Regal scanner, which is purpose-built for mapping, the rest of these scanners are designed for industrial and automotive purposes, and they've been repurposed to mapping. So not very many of them do a very good job at that. So we really spend a lot of time evaluating the scanners to see if we can get the metric accuracy, the low noise, the repeatability, and so forth. And so we're very careful in this selection process. We have a complete post-processing workflow of software that comes along with our sensors. That's critically important. You don't want to go buy a sensor from company A and software from company B and some other technology from company C and try to make that work yourself. You're smart, of course you can make it work, but every time you have a problem, you wind up with fingerprint pointing between vendors. When you acquire a TruView system, we own that solution. So if you're having a problem with geocoding, all the way to automatic ground classification, which is a capability within our desktop software, you deal with one technical support group. And I think we do an outstanding job on technical support, an important aspect of deploying these systems. All right, so still on the vein of what we have in place right now, in March of this year, we added support for DJI's Phantom 4 RTK system and the M300 RTK with a P1 camera for post-process kinematic workflows. And what that means is you can flow the data from these systems directly into our software. You can use your Trimble or Leica base station or your Topcon base station or whatever you happen to be using in a PPK mode. You don't have to use the DJI base station and produce photogrammetric output from these. We've also integrated Trimble RTX so that if you don't have a base station or something happened to your base station, you can purchase that in a metered fashion, so by the minute. So it makes quite a nice workflow for those photogrammetry systems. We've also got a cloud-hosted solution called TruView Reckon, software that we've built and deployed in Amazon Web Services that is a customer portal. So if you're a service provider, you can use this for your customers. It's quite nice. You get an account with your TruView sensor purchase. Some functions within Reckon are at no charge, others are typical charges based on data quantities and so forth. You can build customer sites. So for example, you have a customer who's got multiple sites that they fly either on a routine basis or maybe even one-offs, and you can publish data that you've produced in our TruView Evo software directly up to this Reckon portal, where your customers can have a view of their data. So for example, this was a mining volumetric survey. You can see we've got polygons. I can download a volume report directly from the website, even in Excel format, which is what the financial people of mining companies want. We have a hillshade view of it. We can look at orthos, etc. We also have 3D built into the system, so you can launch into a 3D viewer if you want to explore it in full 3D, and we support redlining as well. So if a customer wanted to go in and tell a service provider what they wanted flown at the site, they could come in, draw a polygon, annotate that polygon, and so forth. All right, so that's what we have today. A full suite of hardware, a really nice set of software to make that hardware work productively. And the real purpose of this webinar today is to tell you the new stuff that we're doing. I'll first cover hardware. All right, so the first thing we've done has been out for a while now is that we built a proper mount for our sensors, 410 through the range. I'll talk about some of the new ones in a moment. For the M300 RTK, this has become a particularly popular drone in the United States, and we've got resellers in various parts of the world as well as our subsidiary JV partner in Australia, and I think it's universally popular drone. So we built a proper mount for it. Beware of scanners that attach directly to the down gimbal mount on the M300 RTK. That down gimbal mount with the Skyport only has a capacity of 850 grams, so make sure your LiDAR system is not overloading that. So all of our LiDAR systems come in at more than 850 grams, so we built a custom anti-vibration mount for it that is, of the proper characteristics to carry a heavier payload. The only sensor I'm aware of that can mount directly to the skyport and not violate this weight requirement is the DJI L1. New, hot off the hardware presses, if you will, is our TrueView 435. I'm really excited about this scanner. It uses the Pandar XT, the same scanner that we use in the TrueView 515, rather than a 32 beam, really ultra density that we have with the 515. This has 16 beams, which cuts the pulse repetition rate down to 320,000 pulses per second. It's a dual return system, just like the 515, has the dual photogrammetric cameras, full software included, and you can fly it on the M300 RTK. This thing is available under subscription or purchase options, so you've got some selectability in that. I really think that you won't find a better entry-level system anywhere in the world than the TrueView 435. You got 120-degree field of view, true colorization of the data over that same field of view. This is an efficient scanner, and it's got tremendous wire detection. I'll show you a little bit of that later. I'm really pleased with this, the way this system has come together. So we've had some requests for Regal Minivux on an M300 RTK drone, and so we've responded to that with our new TrueView 635 compact and 640 compact. Here you see a rendering of it on the M300. Here's a rendering of the design, and it's more than just a rendering. We have an alpha prototype that I reviewed last week. It should be test flown this week, and this has come together very nicely. So this is coming in complete full system at 2.5 kilograms of payload capacity. Of the M300 is 2.7, so we've got plenty, and of course they built headroom into that, so we got plenty of headroom on it. The only real difference between this and the current line of Regal systems we have is that this is powered from the M300 drone. That makes it quite nice because that's got extended flight time. You don't have to worry about charging a separate battery. And we've also built a completely new computer for this system, what we call the core compute unit. We use some advanced technology, Google TensorFlow processor, et cetera, that we built into our own board. We've got our own timing electronics and so forth. Again, 120-degree field of view for both the LiDAR data from the Regal and our dual cameras. This is a 5-return system. New stuff in the software arena. So we're really well known for our software. We started out doing software and did that for years before we started into the hardware. So we really had a leg up on a lot of other companies in terms of, okay, you collected the data. Now what do you do with it? How do you fix it up? How do you make something useful for customers out of it? Our Evo software comes with every sensor. It includes everything from automatic ground classification to automatic wire extraction, automatic rail. There's just a complete suite of point cloud processing tools in that software that's been around for quite some time. That software had its genesis in probably about 2007, so it's mature, advanced software. We've integrated photogrammetry into that by integrating Metashape from Agisoft directly into our TrueView Evo software. So this is a version of Metashape that is what we call headless, or it doesn't have, it's command line driven, it doesn't have a GUI, and that enabled us to directly drive it from within Evo. So this is really, really nice because you can do all your photogrammetric processing from within our Evo software without ever exiting. And this works for the photogrammetry systems as well, like the P4 RTK and also the M300 with a P1 camera. When you're running it with a TrueView Evo system, or we'll talk about the DJI L1 as well, you can inject LiDAR into the solution as the surface model. And I'm going to show you what a difference that makes. If you're doing LiDAR work and you're going to deliver an ortho, you're really going to want the surface of that ortho to be derived from the LiDAR data, where you can get a ground model as opposed to the first surface that you get from photogrammetry. You can inject information from the POS system on angles, and that will fix up photos where they can't correlate in Metashape because of vegetation. So that gives you a much better ortho, and so forth and so on. So you can do other things with this software built directly into Evo. It runs as a background dispatch job from Evo. That means you can tell Evo what you want to do. It'll run as a background process, and you can go use Evo to go do other things. You can also queue, you can do job queuing. This is really nice too, because if you're doing pure photogrammetry like the P1 or the Phantom 4 RTK, you know that can take hours and hours of processing. One of the big advantages of LiDAR, of course. So if you've got 3 or 4 jobs, you can just put them in the job queue, and when you come back after the weekend or an overnight, they've processed automatically. Very efficient. Here's an example of an ortho made using LiDAR data. The other thing we just announced that we're pretty excited about is geometric correction, what I call dynamic geometric correction for LiDAR data. Now, we've got the best calibration on the market. We use rigid aluminum frames between the POS, the camera, and our LiDAR unit, so we really don't have a problem with misalignment and so forth. The real issue is dynamic drift of the IMU, so heading errors over time, and drift of the GNSS over time, especially when you do multiple flights. So this is the physics of the situation. There's nothing that can be done about it. It has nothing to do with the sensor itself. So on large projects or multi-flight projects, it may be necessary to do some dynamic correction because of those drift problems. We've teamed with a company called BaseMap Solutions, who's quite good at this. We've been working with BaseMap for over 2 years to come up with a solution that did not require any kind of tuning parameter. So this software for doing geometric corrections is notoriously difficult to use. We've been training some other solutions since we've been in business, and it really takes quite some time to become an expert at it. Well, with Strip-Align for Evo, there's nothing to do but click what it is you want to geometrically correct, say where you want to put it, and go run it. So no parameter settings. And it also runs as a dispatch, so you can queue up a few jobs, run them in the background, not tie up your Evo, just waiting around for this software to finish. Here's an example where we've got multiple flights. So it's not multiple, it is multiple strips, of course, multiple swaths of data, but they came from different flights. So we flew, we landed, we did something, we took off, we flew again, and we're tying these multiple flights together. And you can see superimposed, it was 10 centimeter grid. Now this is grass, it's vegetated, so you would expect all this fuzz, but that's not really the problem. But you do see some separation between the blue band here at the bottom and some of the red at the top. So that's pre-running Strip-Align. And after Strip-Align, you see quite a bit of improvement in this data. So that's what that does. It does dynamic geometric correction to the data. Works on power lines. So this is really important because here I've got, again, same sort of project. I've got 2 different flights. I've got orange points that came from flight 1, magenta that came from flight 2. And of course, I flew over the same area power line, obviously. This is a 10 centimeter grid. So I've got about 25 centimeters of spread in this data. And a lot of times this spread in power line data, it's up in the air. You're looking at it in a hip shot in many cases. So some of it comes from heading drift, et cetera. And look what we've got after Strip-Align. So we've got a much tighter group of wires. Why is this important? Because if you're doing automatic wire extraction, if the bundle gets too big, the automatic extraction software says, aha, there's 2 wires or there's 3 wires in this bundle. So here we might get some confusion about how many wires we have in the bundle. Now, actually, well, when I looked at this data in the before, I thought this is pretty amazingly good. And it shows you this is raw TrueView 515 with no correction at all. It is really rather spectacular. But you can see that after Strip-Align, I've pulled it in by perhaps 10 centimeters. So it does make a difference. We've also enabled Strip-Align for Evo in a metered mode. So we thought, if you own a 515 or 435, you're going to want a perpetual license of Strip-Align. It's not very expensive. You're doing a lot of flying. But if you're using something like a DJI L1, it means you've just started in this business and you may not want to invest a tremendous amount in software. And so we have a metered capability with this software as well. So you just pay for it by the minute. And that's really convenient. So you don't have to buy the perpetual license. You can go do inspection. We have quite a few inspection tools in Evo. And if it looks like you need to do a Strip-Align improvement, you can just use it in an ad hoc fashion. So this gives us a complete workflow from plugging in the data, importing it all the way through making finished products, including automatic ground classification, building DIMMs, brake line enforcement, conflation of features. The list just, it's a quite extensive toolbox that will handle most of the kinds of deliverables that you'll need to produce. And the thing is, it's very efficient. You don't have to leave the Evo environment to go do other parts of the job. Now, as a bonus, we've also got Evo Explorer. So this is a viewer that looks similar to Evo, but it is used for viewing as opposed for data processing. And you can give this to your customers, or you can use it internally if you like. And you can do all the things you can do in Evo. You can view a profile, view by color, view in 3D, explore, measure, so forth and so on. But we also have the ability to click on a 3D point anywhere in the point cloud and bring up in a viewer all of the images that see that point. Great for inspection. So here I've got in the laser colorized LiDAR point cloud on the left, which that really looks gorgeous, doesn't it? This is again 515 data. I can click on one of these points and I'll see in the images what the different camera images that are seeing that point. So here I can see the insulator. So this is really important when you're doing things like inspecting attachment points and so forth. Something else we're adding is the ability to go digitize. This will be in the Evo version as opposed to Explorer. So that if you want to put in, some production companies put in synthetic points at the exact wire attachment point, and that's something you can do in Evo. Just recently added this in beta form to the web version. So this is added to Reckon now. So your customers or clients can go view on the web. They can click on a point in the 3D point cloud, and it'll bring up that same set of images. And so again, you can use this for inspection and so forth. This is really important because you've got something like maybe a vegetation encroachment on rail or wire, and you want to say, is this significant or is it not? It can be difficult to see that in LiDAR data. If you bring up all the images, then you get a good idea of what, you can do species identification and so forth. So a lot of value there. All right, spend some time on guest sensors. We've just, we're in the process of adding these. You'll see a bias toward DJI. We've worked with DJI since 2015. They build quality products that work well, especially if you have Evo software. So we support the Phantom 4, the P1 camera, the L1 LiDAR system. P1 camera is really nice, gorgeous imagery. The only bad thing about it is they didn't quite do the focus the way I would have done it. Photogrammetric cameras are best if you cannot set a focus, if they're just focused at infinity. It's hard to hold their calibration. Now, a new thing we've done is complete integration of the L1 LiDAR system into Evo. So the L1 from DJI is based on the Livox Avia scanner. This has become a really popular LiDAR scanner. It's used by quite a few companies who are making entry-level LiDAR systems. Interestingly, Livox is owned by DJI. So if you get a scanner built by somebody besides DJI, you're still getting a DJI LiDAR scanner. It's a pretty narrow field of view at 70 degrees. N-track is 4.5. N-track doesn't matter so much because the drone is in motion, and so the N-track is picked up by the drone motion. 240,000 pulses per second, less than a lot of other scanners, but remember that 240 is focused into a narrow field of view, the 70-degree field of view, so that makes up for that. Claim 3 returns. I've never seen 3 good returns out of a Livox, but you can get good second returns out of it. You need to fly it in what's called the non-repetitive scan mode that gives that 4.5-degree N-track dimension. And when you're doing that, it has 6 beams. So this is a 6-beam scanner that scans in this bow tie fashion. We've been doing a lot, and it's really light. Of course, that's the big advantage. So we're doing a lot of analysis of the accuracy of the Livox itself. And we did that by getting data from companies that are flying Livox scanners built by people other than DJI, because we want to look at things like, okay, if you use a different IMU, does that make a difference? The way you attach the payload, is that different? Do different cameras affect it, et cetera? And we've done a lot of that analysis recently. And so I can speak to the cons of this system. So it's got the narrow cross-track field of view, and we think you're going to have to cut another 10 degrees off it. So we think you're going to wind up with about 60-degree field of view, because it really, the accuracy really degrades at the edges of these flight lines. That's not unusual for scanners that are oscillating, that oscillate back and forth instead of full rotation. high horizontal noise. Everyone, we look live ox from everybody, and they're fuzzy in the horizontal direction. To me, that kind of puts them more in the class of a topo scanner, not something you would use for 3D visualization and so forth. The most serious issue is difficulty discriminating multiple close returns, and this generates something that I call error points, and we'll talk a little bit more about that lately. So all of these LiveOx scanners are going to perform about the same. My own opinion is that if you're going to get a LiveOx, you might as well get the DJI because it's gimbal mounted. So I'll show you why a gimbal is important in a moment. They fly on the Skyport. So I saw some company that's got a mechanical mount where you can land and you can rotate the scanner by 90 degrees and then go fly it again if you're going to image something like the side of a bridge. Well, why not just get an L1 with a gimbal? You can do it electronically without having to land, et cetera. It just makes more sense. This has a really interesting, it's got an integrated camera. It's the same camera that's on the Phantom 4 RTK, a 20 megapixel fixed focus, mechanical shutter. So it's a pretty good photogrammetric camera, but they've also added an optical flow camera. So this is a lower resolution camera that's used to improve IMU heading. So that's novel in a LiDAR system. Now, using optical flow to improve heading is not novel. That's a technique's been around forever. But it's pretty new to pointing systems in LiDAR scanners. So it's interesting. I'm not sure how effective it is. We're analyzing that. And of course, it's pretty inexpensive. So I've seen a few integrators that are saying, hey, we're a lot more expensive than the L1 from DJI, but we've got a better IMU. But I'm telling you, the IMU is not the problem with the LiveOx scanners. Talk briefly about roll compensation, because this is why you need a gimbal on these narrow field of view scanners. On the TrueView system, we've got 120 degrees to play with. Typically, you're going to use less than 90 degrees. So as the aircraft rolls, we can just dynamically readjust what nadir is and still give you a full, like if you said, I want 45 degrees on both sides of nadir, then we can adjust that and give you nice straight flight lines. So we dynamically adjust that for each roll of the aircraft. We call that TrueTrack, and it works quite nicely. If you don't do any kind of roll compensation and you don't have a gimbal, you can wind up with what we call roll holidays. So here we've got a dramatic example of that, where we've got the blue flight line or the cyan flight line, quite a bit of roll, and then we've got the orange flight line, and they both happen to roll the wrong way. And here we've got a big gap between them where there are no LiDAR points at all, and we call that a data holiday. So narrow field of view scanners, you're going to have either a lot of overlap to prevent that from happening, or you're going to have to be gimbal mounted. Here's the serious problem with the LiveOx and other scanners of its ilk, and that is the way a time of flight LiDAR works is it sends out a laser pulse and it gets an echo back from that laser pulse, and it measures the time of flight. Multiple return systems have the ability to you pass a branch and then you hit the ground or something like that, and you can get some reflection back to the scanner from the first hit and more from the second. That's multiple return. One of the important parameters of a laser scanner is, well, how close can those objects be before it blurs them together? Here I've got a graphic of that. So each one of these Gaussian looking pulses, they actually are Gaussian, represent the laser impacting some target and sending an echo back. Usually they'd be of different amplitude, but that's immaterial to this discussion. And they're pretty close together in time. And what happens is that the sensor is not sensitive enough to detect that these are two separate pulses. It convolves those pulses together and it says, I've got a wide pulse and here's the center of that pulse. Well, it's out in the air, and that's why I call this an air point. There is no object there. Interestingly, Regal has a per point metric where they actually give us the shape of this pulse in data that we can read in TrueView Evo. Other scanners don't have that. Here's the result of that. So here I've got, and this is not an L1 from DJI. This is a LiveOx Avia scanner on a different system, and we're looking at a sine gantry over a highway. It's a lattice beam structure. We should be seeing clear lattice beam segments in here, but we don't. It's just a big mess of points all in places where there are no objects at all. So these are all air points. and they're caused by this inability to do discrimination between multiple returns. Here we see an impact on the ground where I've got a stanchion for a sign, and the stanchion should be the shape of these green points, but you see this band of yellow that's going up the slope of this. And again, these are air points. So yeah, you can use the AVIA and topo work where you're looking primarily at ground and you don't have vegetation too close to the ground, because you're going to have these air points somewhere between ground and low vegetation too. You can have a problem there. So you want to be careful with that. Wires is a big problem. So if we look at the Livox AVIA on some distribution wires, you can see all these air points in here. So there's a bundle of 3 wires here. They're all mixed together. Automatic wire extraction software is not going to be able to differentiate those, and it's probably going to give you one fat wire out of that, as opposed, and by fat I mean it's going to say I found a wire, but the noise is enormous on it, the standard deviation of it. Here's our new 435 using the Pandar XT, and look at this beautiful, just beautiful wire separation. I've never seen wire separation this good in a LiDAR scanner in this price range. It's just incredible. I would defy anyone to show me a sensor that can do this in that same price range. Here's the 515, which is double the density of the 435. And again, you just see beautiful separation in these wires. No problem whatsoever of extracting these as individual catenary curves. So this is important toward the wire collection business. That said, a lot of people are going to use the DJI L1. It's a great scanner. The Livox AVIA is a great scanner for topo work, again, in limited, light vegetation, things like that, particularly if the vegetation is not too close to the ground. So we've integrated this flow into our software, into our Evo software, and that includes Metashape for Evo and Strip-Align for Evo. There's some problems with a number of these implementations of Livoxes in terms of data formats and how it divides up strips and so forth, and we've fixed that within the Evo workflow. All right, so now we're going to try some software demos. Nothing up either sleeve. This is dangerous stuff, because the demo detector is usually on full force. So what I'm going to do is I'm going to show first I'm going to show an L1 import. So I'm going to import a cycle, what we call a flight, into Evo. This is a DJI L1. You see it showing up here as a guest sensor. And I still have to use DJI Terra to do the encoding of the data. And once that's done, I just go browse for the raw data and the data that came out of Terra. And you see it gives me a lot of information about the flight, how many photos there were, the length of time when the flight started, ended, etc. I could give the project a name. I'll call it L1 test 456. I've run this so many times, maybe that won't collide with an existing project. And I need to set the coordinate reference system. So I've got a quick picker. I've run this before, of course. So it's Alabama West ellipsoid meters in NAD 83 2011 realization. If that's not the right one, then we've got a wide selection of coordinate systems, and of course supported not only in the US but in Australia, Canada, many other countries, Africa, etc., Europe. And then I finish this, and this will import the project. For this particular project, it's a pretty small one. It takes about a minute to import it. Instead of doing that, I'm just going to go open the project, the same L1 project that was the result of this import. This will load up, and this is what it looks like. As soon as I say finish on that wizard, I wait 1 minute, and then in comes the data. And this is just the raw data from the L1. So I've got, and notice we have a nice Google backdrop. You can go change that to other map backdrops. That's the actual data that was input. I've got the complete flight path. We superimpose this with 1 second points for a variety of reasons. It gives you a nice look at how much time there is between events. And then you'll notice that the flight line is, or the LiDAR data is all collected in one group. And then the green dots are the photos. So I'll turn off our timing points so we just see what was produced by the DJI. And if I go in and say, And you see this is true 3D in Evo. So there I'm viewing by elevation in 3D, and the feature data is 3D as well. We get a good idea what the flight looks like. And then if I go view this by flight line, you notice that it's not encoded. So DJI does not give us encoding for the flight lines. That's a real problem because that's the domain in which I need to do geometric analysis. So that's going to be a problem. And then if I go look at the LiDAR data itself, and we've got a nice detailed LAS file analyst and repair tool built right into Evo, then I see that this is version 1.2. Alas, 1.2 is 8 years old. 1.4 is the current version of LAS. The spatial reference system is encoded as EPSG. That's not correct either. Should be WKT, so forth and so on. So this kind of data could be rejected by a lot of customers. Now, for some reason, I guess there must be an open source library that makes 1.2, because every LiveVox scanner I've looked at from different manufacturers is coding to LAS 1.2. So you really won't want that. So you'll want to fix that up. Now, the color itself, it's not awful, but it's, you can see a lot of banding in here, and there's a lot of horizontal fuzziness in these scanners. So you don't have true view quality here, but it's certainly recognizable. Definitely better than no color at all. The intensity on these systems is quite nice, so I get really nice intensity. That looks pretty good. Looks pretty good. All right, and so what can we do with Evo to fix this up? Well, I've got it in as a project, and the first thing I do is I say, well, I need it divided into flight lines, so I run, and this is just a wizard. You run step by step, and I want to generate flight lines, so we've got an automatic tool to generate those. Got parameters you can set to tune them to different ways. And here I've got 2 ferry lines, 3 flight lines. I don't want to process the ferry lines. I'll get rid of those 2. So I just say I'll delete those guys. All right, good to go. And now what I need to do is I need to make a proper trajectory for each flight line. So that's a 200 hertz vector that gives me pitch, yaw, roll, XYZ at 200 hertz. And I use that in geocoding LiDAR, in strip alignment, all kinds of other processes. So I'll bring that up and run it. We pull the sensor calibration out of Reckon. We don't have this one loaded in Reckon, so we made up a calibration file for it, but normally we pull that directly from our cloud. And you can tell the system that, hey, as far as photos go, get rid of all photos except the ones in flight lines. If you're making orthos and all, that's typically what you will do. And then we can also update the information on the photos themselves with what we call true pose information. And I'll show you the value of that in just a second. So we go ahead and run this. I should have kicked it off when I was talking about the dialogue. And what it's doing is that it's reading a lot of data from the information that was provided by the DJI Terra application and rebuilding some proper trajectories. Now I've got 3 trajectories. These can even be used in tools like TerraScan, for example. They're compatible with anything that'll read TerraScan format trajectory. So now if I go colorize, well, let me geocode the LiDAR. So I've fixed up the trajectories. Now I need to fix up the LiDAR, and I have a few options on fixing up the LiDAR where I can say I want to clip it. So remember I said, you probably want to get rid of 5 degrees on both sides of the scan line. So it's normally 35 degrees is the width of these scan lines. I could clip it to 30 and get rid of those 5. I could do that after I do this processing if I want to. And I can also do a clipping range where I can say, clip data that's close to the sensor. If I go now in geocode, so I still have the color, I can turn on color, and that comes through unadulterated. I go look at the LAS data itself in LAS file analyst, and you see now I've got a proper 1.4 with WKT SRS encoding, spatial reference system encoding, quite nice. And very importantly, I've now got defined flight lines. I've got my data colorized by flight line. So this is Well, I think it's a requirement. I wouldn't say it's a nice to have. This is a you have to have it if you're going to do geometric analysis of your data. And if you don't do geometric analysis of your data, your customer will. So you better be doing it. And we've also encoded all the images, so I can now use the images in Image Explorer. So I can click on, say, the railroad tracks, and here you see them in Image Explorer. This particular job, our camera was a little bit out of focus, but you can see that throughout the data set. So this is really nice. I can do inspections directly from these data. Now let's have a look at how the geometry looks in the sky. So I'm going to go turn on color by flight line again, and I'm going to cut a little profile in some area between these flight lines. So let's go down here. Let's make them pretty narrow. And we'll look at this and we'll colorize our profile view by flight line. And alas, yeah, you can see out here this separation. Not horrible, not horrible. But you can see I'm out the edge of the blue flight line, and that guy is it's starting to get a bit fuzzy, etc. So strip-align would definitely help this project. And so I would like to run that, and I do that with a tool built right into Evo. And I say, I want to run strip-align. And let me bring that up one more time to show you the metered option. And so you can see that it's really simple. So I want my LAS, my fixed LAS is what I want to run. I just want to put it on a layer that I'm going to call, let's say, strip-align LAS, LAS. Really all there is to it. I just say, go submit it, go do it. That's off running. And then the other thing I might want to do, so that's running in the background. I can come look at my processing tool, and it says in progress, running registration. So there's that job I just launched. I've got a job manager to have a look at it, but I want to go do something like perhaps run an ortho photo on this. And so we have built into the system Metashape for Evo. And so you see it's as simple as selecting the photos you want to work with, the DIM if you're going to inject a DIM, and I can do generation of an ortho from a DIM. That's the most common thing you would do in a LiDAR workflow with cameras. If you're doing pure photogrammetry, then you would generate a point cloud and ortho from the images, be like for the Phantom 4. You could do it with the cameras from a TrueView sensor and from the L1 if you wanted to, or you may just want to do bundle block adjustment, and that just improves the accuracy of the photos. I'm not going to run this right now, but I'm going to show you the results. So you can see it's pretty simple. Anybody that's run Pix4D or Metashape in its entirety says, ooh, that's quite a bit less complicated than what I'm used to seeing. All right, so I want to go look at the strip-align results. It takes about a minute to run this project. So instead of you waiting around for that, we'll go switch to the where I've got the finished data. Yeah, I'll save that project. And now I've opened up a new project where strip-align has already run. Same L1. So from the time I imported data from an L1 to this point, we're still working in that same exact project. I've got my LiDAR data colored by flight line, and let's again cut a profile through that original data set. Colorized by flight line to do this. Alrighty, and we'll cut a profile here. And we'll look at this. So this is the original data, and again, you can see in the blue and the green, this separation of data. I'll toggle this over to strip-align. And look at that. So it brought that data together very nicely. No parameters to set. Golden, this is great. So extremely easy to use. And now let's look at something else. I also made a ortho using I took the data that we had a minute ago, the L1 data. I did a ground classification using our automatic ground classification tool in Evo. I didn't do any cleanup to it, so it could have a few defects. I was just doing a quick and dirty. And let's look at a ortho that is made from structure from motion. So this is where I'm just using the ortho data itself. And then to make you seasick, I'll change my background so I can see the holidays in this ortho. And so you can see here in vegetated areas, I've got these holiday areas. But the worst part about it is look at all this blurring I've got. You know, if I'm delivering this to my railroad client, you know, they're not going to be too happy with what this ortho looks like. Let's have a look at the ortho that we made from the LiDAR data. And look at that. So this is, again, running Metashape, but now we're using LiDAR as the base elevation data, not that surface model that's got holes in it. And you can see what a vast improvement that is. That's a gorgeous looking ortho. But not only that, look what we've got here where I look at the structure from motion. So if I'm doing an inspection of track, I'm going to say, yeah, this vegetation is starting to encroach, but it's not overhanging the tracks yet. But in fact, it is. So you get displacements when you're not using, let me turn on the right ortho here. And you can see this is the true location of the vegetation. So that's something that you really want to be careful with. And now I want to look at one final project, and this is to compare, to get back to our own sensors. Yeah, we can save that project. I probably want to turn that backdrop off. You notice I've got this blinking check mark over here, and that's just Job Manager saying, hey, your job finished, time to post-process. We won't do that because I'm in a different project now. Let me get this background color back to something that we can live with. And so we want to look at is a comparison of sensors. So the first one is we look at a L1. This is LiveOx, and we look at the color matching of the LiDAR data. You can see it's really poor. I've got multiple stripes in my parking lot when in fact there'll only be one. If I look at a TrueView 435, much better. That's what it's really supposed to look like. And again, that's part of that horizontal separation that we typically see in that LiveOx scanner. And now here's our machine shop, and we've got an old satellite dish. We were going to take it down, but gosh, it was a great conformance tester. So this is a satellite dish. I'm not sure you could tell it by this image. So here it is. It looks kind of like an amorphous blob. I do have a couple hits on the antenna, but the dish itself, I can't really tell what it is. Let's toggle that to a 435. And now, look at that. Yeah, that's quite clearly a nicely defined satellite dish. That's lovely. So we really like that. And then now let's have a look at the 515. And you see with the 515, it just increases the density. So I've got just tremendous conformance. Looks great. Let's have a look at those wires. We've got some distribution wires. This is a real test. So we're not doing transmission, we're doing distribution. More of a challenge than transmission, of course. And let me roll over to the wires. And so let's go to the LiveOx Avia scanner first. And here's this issue that I was talking about. Just look at those fly points in this real data. That's pretty tough, pretty tough. You're not going to automatically extract those wires. 435, our brand new scanner. And look at that, just beautiful, nice separation, low noise. And this is distribution, not transmission. These are not big wires. Oh, and the altitude on all three of these was 75 meters. We're pretty far from the wires. We're not having to sit down on top of them. And now here's 515. We call it, you know, it is the wire. If you're doing wires, that's the sensor for you. And just look at that. Beautiful separation, high density, high quality data. All right. So quick summary on the sensors, or on what we've talked about, you know, from mounts, TrueView 435. If you're going to do an entry-level scanner, get the 435. It's not going to let you down. And then we've got our new compact coming out where you can put a reel on M300. fully support the LiveVox if that's the direction you've decided to go. We do a great job with that, as you've seen in our software. And then, of course, Strip-Align for Evo and Metashape flesh out that entire workflow, and Reckon stays caught up with these applications as well. You know, we don't think you ought to process in the cloud. Why would you send your LiDAR data up to the cloud and then have to bring it back down again? But it makes sense to distribute data and publish data in the cloud. Those are the sensible uses for it. All right, and with that, I thank you very much for your time, and I turn it back over to Crystal.
Thank you, Lewis. I'm going to pass it over to Madeline as we cover our business section just really quickly before we wrap it up.
Thanks, Crystal. Can you see my screen okay?
I sure can.
Okay, I'm going to breeze through this pretty quickly and try to get out of here at the top of the hour. So I'll just quickly cover our TrueView systems in a little bit of detail, and we'll share some PowerPoint slides that have a bit more detail after the webinar. So talking about our TrueView line of systems, the 435, 515, and 635, 640. So what's included? Of course, the main sensor unit that you choose that's integrated with our dual GeoCube mapping cameras, the control box antenna kit, storage media devices, 2 batteries, each battery having roughly 90 minutes of flying time, a battery charger, and a Pelican carrying case. And then we also include 2 days of training, which you can choose to attend in person at our office in Huntsville, or we also offer it virtually. Our new 435 is priced at $55,000 per purchase. It's also available under a subscription, the 1 month starting at just under $7,000. This price includes our TrueView Evo software, as well as PAWSPAC UAV that's used to process the trajectories from the APX system in this 435 system. Our 515 system is priced at $75,000. The good news is if you start with the 435, it's very easy to upgrade to the 515 system. We also offer a subscription offering with the 515, priced just at under $8,000 for the 1 month. If you purchase the 515, we include our TrueView Evo software, PAWSPAC, Metashape for Evo, and Strip-Align for Evo. Our 635, 640 system, priced the same for both the compact and the standard version of the system. Our 635 is priced at $164,000 and our 640 at $199,000. This includes all of the software, Evo, PAWSPAC, Metashape for Evo, as well as Strip-Align for Evo. Selecting a drone platform, so we can integrate on the DJI M300 and M600. We've also integrated on numerous other platforms, including the Harrius Aerial, Inspired Flight, Skyfront, FreeFly, and Watts Prism systems. Outside of selecting your drone and sensor, you'll want survey equipment, L1, L2 with the ability to export a RINEX file. Our recommendation is a base rover kit so that you can collect checkpoints. Our next training session in person will be on December 8th and 9th. We spend a half a day in the field and then a day and a half covering the software workflow portion. Again, we offer this virtually for those that it's more convenient not to travel. I won't spend a lot of time on this, but again, as Lewis touched on, we're excited about all of the new additions to our TrueView Evo software, including the addition of the L1 workflow. And again, our Evo software has lots of tools, including classification, break lines, visualization, QA/QC, product generation. We are DJI Enterprise distributors, so we supply both the drones bundled with our hardware and software. So we've got starter kits for the DJI P4RTK and P1, as well as the L1. The price of the Evo software that we recommend for working with the DJI hardware is priced at $2,500. And of course, we recommend Strip-Align for use with the DJI L1. This module is available for $2,500, or you can purchase it by project. We're excited to share all of these updates with you today. And whether you're just getting started or you're ready to add to your existing fleet, we hope you'll choose GeoCue as your supplier of technology. So with that, I'll conclude my portion of today's presentation, and I'll hand it over to Crystal for one final poll question.
Thank you, Maddie. I'll go ahead and switch it back over to me to launch that last question. All right. And for our last poll question tonight, it is, what is your interest in the TrueView solutions? If you have any questions, feel free to email us at info@goq.com. Thank you again to Lewis and Madeline, Martin and Mark for joining us on today's webinar, and for everybody who attended. We hope that everyone continues to stay healthy and safe. This webinar has been recorded and will be distributed to everyone registered. Thank you again for joining us, and we hope to hear from you soon.